At the other end, it is very, very similar in nature, except that it is going to happen in the reverse. In data de-encapsulation, which some people refer to as unencapsulation, the bits themselves are received at the physical layer on the network medium. What happens at first is that every system on the wire will actually view the layer 2 header to see if the MAC address matches their own. If the MAC address does match their own, then it indicates that the packet is in fact for them. However, any host that does not match the local layer 2 header will discard this frame and will not examine it any further. Once the layer 2 header is verified by the receiver, indicating that this data packet was in fact destined for this particular receiver, the receiver will actually perform its own check of the information from the layer 2 header all the way through the user data using the same type of mathematical computation, which is media specific. It will come up with its own answer. We'll then look into the frame check sequence field and figure out what answer the sender actually identified originally. If the two answers match, it indicates that the frame was received correctly, and thus the frame check sequence has actually served its purpose. The frame check sequence is sometimes referred to as the CRC, or cyclic redundancy check. Once layer 2 has been verified, the remaining data would be passed up with the layer 2 header stripped off. At this point, the network layer is going to identify any layer 3 information, such as the source and destination addresses. Verifying this information, it will strip off the layer 3 header and pass the remaining data to layer 4. Now at layer 4, which is the transport layer, we typically have something like a port or a value, which is used to send the data to the right application. Any information which needs to be executed at this point can be executed, and the remaining data would then be passed up to the appropriate session level and application level component. Here at layer 5, session level information is stripped off. Layer 6 information is applied and then stripped off, finally leaving us with nothing but the application layer data, where authentication or synchronization of peers may have occurred. Once layer 7 has its job done, then plain user data is passed up to the physical application or the actual application. Now there are a couple of points about data encapsulation and data de-encapsulation that are very important. Not everything that a sender and receiver will do happen inside of a single packet. So we will see that every one of our layers is required. Certain things will happen in certain times. Let's say that an application requires authentication before any data can be sent. Authentication has to happen at layer 7, thus everything else that occurs below layer 7 is all based upon supporting this authentication routine. So when the sender will actually send the data from layer 7 during the data encapsulation process, the layer 7 component will perform authentication. Everything below it is going to be in support of that authentication request. Thus, when the data is received during the de-encapsulation process, anything that is stripped off down below is fully in support of that authentication itself. In fact, when systems are communicating with each other, they both must be utilizing the exact same protocols and information on both sides so that the processes that happened at the functional layers of the OSI model can actually do their job. This is what is known as peer-to-peer communications.